Chapter 3 is exponentials and logs. Okay, exponentials, logarithms. You know, right now, today, looking at exponential functions, working with exponents. Yeah, exponents. So knowing how to tell if something is an exponential function, what an exponential function does, what it looks like, you know, just some basics here. So exponential function is going to be of the form f of x equals a times b to the x, where a must be non-zero, because if a is 0, face it, that equation doesn't exist. B must be positive, so in appropriate exponential form, your base is positive, and b cannot equal 1, because 1 to any power is still 1. So a little bit of vocabulary here. A is the initial value, so that's what we'll talk about, A being the initial value. It is the value when time is 0 or when x is 0. Okay. And b is the base. And those are two things you're going to be asked to identify here are initial value and base. So you need to be familiar with those. Key characteristic to identifying an exponential function. If it's an exponential function, where does x have to be? X has to be in the exponent. If x is not in the exponent, it's not an exponential function. So just keep that in mind when we talk about exponential functions. Exponential function was one of your 12 graphs, right? So it is one that you should be familiar with. Whether you remember exactly what it looks like right now, I don't know, but look at the bottom of the page, and there's one at the bottom of the page, right? Okay. Okay, so one of the things I want you to be able to do. Example 1, determine whether each of the following are exponential functions. For those that are, state the initial value and base. For those that are not, explain why not. So as we look at example A, f of x equals 3 to the x. Is it exponential or not? What do you think?
Yes.
Yes. It makes sense for it to be exponential because x is where? In the exponent, right? So I'm going to agree that it is exponential. Now, if it's exponential, we have a couple questions to answer, right? We need to state the initial value and the base. Thoughts on the initial value and the base?
Would the initial value be 1 and the base 3?
Mm-hmm. Is the base the obvious one to you guys? Because the base is whatever's being raised to x, and what's being raised to x here is 3. Ireland mentioned 1. Where is there a 1? Well, there's not really a 1 in there, but is 3 to the x the same as 1 times 3 to the x? And it is. Okay, so this is one of those cases where there's no initial value showing, but that's where you have to know, okay, well, if you multiply by 1, that doesn't change anything, so initial value of 1. I'm going to abbreviate if you can handle it. The IV, initial value is 1, and B, the base is 4. Or feel free to write those all out if you want. Okay, easy enough? Okay, B, g of x equals 6x to the negative 4th. Tori?
I'm sorry, but you put B as 4.
That is a very valid point. Why is B 4? I got nothing there. That is an issue. Come on, erase. Seriously? Erase so I can get the... My board is doing weird things. Okay, base is 3, better? You guys all wrote down the right thing though, yes? Or it was just the one that decided to tell me about my silliness? Okay, back to B. G of x equals 6x to the negative fourth. Exponential or not? No? Why not? Yeah, x isn't in the exponent. This is just a typical no, it's not even a monomial. It'd be a power function. Because in a power function, remember, x can be any power, or the power can be anything but 0. So it could be a power function. But it is not exponential. This is not good, folks. My board is doing weird things. Okay, this is not exponential, and my explanation is going to be x is not in exponent. Okay, if you want the reference to the test you just took, this is a power function. Okay, it's x to some power and any power but 0. C, h of x equals negative 2 times 1.5 to the power of x. Exponential or not exponential?
By it saying that b is positive, does that have to be whole numbers or just positive integer?
Just positive. It does not have to mean whole numbers.
So I think it is exponential.
I can agree. Okay. There's nothing that says our base can't include a decimal, which could be expressed as a fraction. Happens to be decimal form here, but yep. So this is exponential. And initial value of what? Negative 2. It's the a value out front. And we'll try and get the base right this time. A base of 1.5. Okay. Okay, D. K of x equals 7 times 2 to the negative x. Exponential or not? What are you saying, Ethan?
Yeah.
And why are you saying yes?
Because x is in the exponent.
Okay. X is in the exponent, right? So it is exponential. Now the twist is when we go to do initial value and base, specifically the base, we have to do a little tweaking though before we can give that information. Because based on our basic exponential form, it's a times b to the x. So the b is raised to a positive x. So we're going to have to do a little tweaking. However, it is exponential. It may be an x up there, a negative x in the exponent, but it is still exponential. Okay? My suggestion here to help you think about this, 7 is 7. We already know that, right? And it's 2 to the negative x. Negative x is the same as saying negative 1 times x. And so if I separate that and say, okay, this is 2 to the negative 1 raised to the x. Now do I have it as some number raised to the power of x? By pulling that negative off and attaching it to the 2. What is 2 to the negative 1? Or 2 to the negative first? What? 1/2? Because what's a negative exponent tell us to do? To make a negative exponent positive, you take it to the denominator, right? So if it's 2 to the negative first, you make it 1 over 2 to the positive first. And so this is 7 times 1/2 to the x. That's the form I would encourage you to have it in to think before you answer the question of what is the initial value in base. Okay, pull that negative off the exponent, put it with a number, and readjust. So based on that information, my initial value is 7, and my base is 1/2. Okay, so be in that, appropriate form to do that. And I just drew over that x, but. Okay, one more in this section. E. Q of x equals 5 times 6 to the pi. That is a pi there in case you weren't sure. I've just verified that for you. Thoughts on whether or not it's exponential? I see head shakes. Why not? There's no x. I mean, the small piece of it is there's no x in the exponent, right? But the bigger piece of it, there's no x at all. Which really, I don't know what 5 times 6 to the pi is numerically. But 5 times 6 to the pi, those are all constants. This is just a constant function. This is q of x equals some number. So this is just some horizontal line. Okay, so I'm going to say not exponential. And I'm going to use the same explanation I said earlier, that x is not in the exponent. You could also say there is no x. I mean, that would explain it as well. Okay, we good on the top section? I've got to keep moving if I want to get through this page. Got it? Okay, example 2 asks us to find the exact value. So I'm going to ask that you not use your calculator here for a moment, because I want to think about what this, how to do these, okay? Some of them are pretty basic. You don't need a calculator. Some of them, I want your brains to do the thinking here, okay? So for f of x equals 2 to the x, find the exact value, which also means if you are to use your calculator and you get a big long decimal answer, that's not what I want, because that's not an exact value. If you have to take a decimal from your calculator and round it, you're giving me an approximate value, and I want an exact value. Now, we'll start off you guys know how to do these, right? If f of x is 2 to the x, and we have to find f of 4, how do we find f of 4? Every place I see an x, I'm replacing it with 4, so we're doing 2 to the 4th. And go another step, don't leave it as 2 to the 4th. 3.1, Craig, middle of the page. So 2 times 2 times 2 times 2, we can arrive at the fact that it's 16. What?
Where's 11 come from?
I don't know. My BenQ has some kind of weird lag going on this morning, because I was really kind of confused by that as well. So, yes.
So I think I understand this one. It's just you take the f and the number and you plug it into the exponent.
Mm-hmm. Yep. Just if it's f of x and they want us to find f of 4, every place we see x, we're putting in the 4. So B, f of 0. Can we do this without a calculator, guys?
I don't know.
Well, I'm being serious here, because some of you aren't going to remember. So, okay, it's 2 to the x, so we're doing 2 to the...
Is there a bug on?
I have no idea. 2 to the 0 Oh my goodness, sorry, I don't know. Watch what I write next time it does that, because I'm not writing whatever it's doing. What is anything raised to the power of 0? 1. And will your calculator confirm that? Yes. Okay, but just kind of a good reminder there. Okay, C. And starting, this is the why we don't want to use a calculator. Because if we use a calculator, well, I guess you get an exact value on this one, but. Okay, so f of -3 says I'm doing what? 2 to the -3rd. This is where I just want to review the math.
1/8.
Yeah. So how do I deal with a negative exponent? To make the negative exponent positive, I move it to the denominator. So that becomes 1 over 2 to the 3rd. But we know we can go farther than that, right? 2 times 2 times 2 is 8, and thus Jacob's 1/8. Your calculator would give, what, 0.125 on that one? Which is equivalent. But sometimes they'll give you a big, long, messy decimal, and you don't want that. So, again, use your brain on these. Next one, f of 1/2. So what's that mean I'm doing? I'm doing 2 to the 1/2. What do you know about 2 to the 1/2? What do you know about fraction exponents? This is one where you could not use your calculator, because your calculator is going to give you a big, long, messy decimal. What do you remember?
Square root.
Yeah, square root. So officially, when we have a fraction exponent, it means there's a radical. My base of 2 goes under the radical sign. The denominator of the fraction is the index. So that tells us it's a square root as opposed to a cube root, a fourth root, something like that. The numerator is officially the power on the inside of the radical. So all of that fancy talk just to say that this is square root of 2. If you do square root of 2 on your calculator, you're going to get 1.414 something, something, something. That's not the answer I'm looking for. An exact answer is square root of 2, because you would have to round it off the calculator. That sounds familiar, right? Okay, one more in this section. F of -3/2. So that means we're doing 2 to the -3/2. Well, we've done all the pieces here. What do you know about negative exponent? Takes it to the denominator. So now I'm going to say this is 1 over 2 to the 3/2. Okay. What do we know about that fraction? That fraction exponent means this is going to be a radical, a square root, base of 2, and this is a square root, because 2 is the denominator, of 2 to the 3rd. Is this all coming back to you? I don't know that we've talked about this lately, but so this is 1 over the square root of 8. How the book would have it depends. We can look at one option that the square root of 8 will simplify, because the square root of 8 has a perfect square in it, has a perfect square of 4. It's 4 times 2, right? So the square root of 4 goes out front as a 2, and then the 2 stays under the square root. I have that boxed in my notes as a possible answer, if you're not forced to rationalize. What do I mean by rationalize? You're technically not supposed to leave radicals in the denominator. How do you get rid of a square root of 2 in the denominator? You multiply by square root of 2. If it's just you're trying to get rid of just a single square root, there's no adding or subtracting. You just multiply by itself. If I multiply the denominator by square root, guess what? Multiplying the numerator by square root of 2. So on top then, 1 times square root of 2 is square root of 2. On bottom, well, what's square root of 2 times square root of 2? 2 times the 2 that's already out front, 4. So your most simplified official answer is square root of 2 over 4. As I said, I have it boxed in my notes that I would also accept the unrationalized version. So, okay, I am running a slight behind because I need to get through this next example and I have 5 minutes. Let's see what we can do with it. Okay, and really there's a part A and a part B here. Actually, there's 3 problems here. I'm not even going to get to B, but. So, use the following chart to determine the exponential function for f of x and for g of x. So right now, notice, there's 2 different things happening here, right? Right now, we're just going to look at the left. We're going to look for using the x and the g of x. Or, excuse me, x and f of x. We're being asked to write an equation for f of x. Top of the paper, what is our form of an exponential function? A times b to the x, yes? So what we need to know, or we need to know A, and we need to know B. Okay. A, if you recall, is the initial value. And I mentioned it earlier, it's initial value when x is 0. What do we know when x is 0? F of x is 4. This is your A right there. Okay? When x is 0, that's always where you'll find your initial value. So I know when I write this equation, I can write f of x equals 4 times, for the base, we're looking for the ratio basically. How are we getting from 4/9 to 4/3 in terms of multiplying? How are we getting from 4/3 to 4? From 4 to 12, and from 12 to 36. The top of that chart may be a little hard to figure out, but what do you notice on the bottom of the chart? What are we doing? That's definitely multiplying by 3, isn't it? 4 times 3 is 12. 4/3 times 3, does that make sense? And then if you even go far enough and think about it, 4/9 times 3. 3 over 1, there'd be a 3 cancel. So what is this 3, am I going to say? This is your B value. So the equation for this one is 4 times 3 to the x. So your initial value always comes from when x is 0. Your base, what goes with the x, has to do with, okay, what are we multiplying up by? Does that make sense? Now, I don't know if I really have time to look at g of x here, but, and realize B is a graph. Can you write down these ordered pairs if you had to and try and do the same thing? Yes, you can. Now, real quick, what's my A value going to be over here for g of x?
8.
Yes, I agree with the 8. Sorry. Troubles over here. So A is 8. Now, have you figured out the whole multiplying thing? Because we do need to talk multiplying. I think the easiest thing for me, 32 to 8 or 8 to 2. Okay, forget multiplying for a brief moment. How do you get from 32 to 8 or 8 to 2? Divide by 4. However, if I'm not allowing you to say divide by 4 is the same as what? Multiplying by The reciprocal, 1/4. Does that sound familiar? So each part of the way here, you can multiply by 1/4. So B is 1/4. Now, when you do a 1/4 like this, put the fraction in parentheses before you put the exponent. Okay? So your fraction base does need to be in parentheses to be in official form so that we know the x goes with both pieces. Okay. I didn't get the graph on B done. I was a little quick on this. Hopefully you followed. Your homework is page 261, 1 through 14. You can do it all. It is due tomorrow. You can do it all. I will say 13 and 14 I think are graphs. So pull those, like ordered pairs from the graph and do the similar type thing here. Okay? I guess I'll write this on real. Oh my goodness. What page did I just say? Hold on a second, Craig, before you leave. There we go. Page 261, 1 through 14.